Hello, everyone. This is your last section of notes for Chapter 2. And we are looking at variation in applications. Those of you who had Mrs. Chin last year, this will be reviewed. Those of you who had me, we have not done this before, so it's new to you. Okay, so what do we have here? We're going to find some equations and solve some applied problems. So what is direct variation? Basically, it's this. All you really need to write down is direct variation is y equals kx, period. That's what you need to know. And k is what we call the variation constant, or the constant of variation, if you want to say that. And really what it is the slope. Because what direct variation is, it's a line that goes through the origin, or 0, 0. And because it goes through the origin, you only need to know one point and able to come up with the equation of the line, because 0, 0 is another point, and that would give you the 2 that you need. So if you know it's direct variation, they like to tell you a fun fact or a point that's on the line, and then we can write an equation and come up with all sorts of predictions. Okay, so direct variation. Now, there are some magic words that will tell you that it's this relationship, and it will say y varies directly as, or it could say directly proportional to. Anytime you read words like that in a problem you come across, you can immediately write down y equals kx, and you will be able to solve the problem. So here is an example of what the graph will look like. If k is positive, it's going to be an uphill slope line like this, and generally it is. And it's always going to be increasing, and it's always going to go through the origin, like I said. Okay, now what is inverse variation? Inverse variation is not by multiplication, it is k over x. Okay, and actually I'm going to go back a slide because I kind of want to write this down. As x gets big, y gets big. They get big together. They grow together, okay? You should have wrote that down too. So for inverse variation, the equation is y equals k over x. K is still what we call the variation constant, okay? And this is not a line. It's actually like it's actually like that, a little loopy in the corner there, okay? And k has to be positive. We're going to say k is positive. Inverse variation, the word you're looking for is varies inversely as, inversely proportional to. So if you read those words in a word problem, you can immediately write down y equals k over x and get ready to solve. And what happens with inverse variation is as x gets big, y ends up getting smaller. So if you look, x is growing and y is decreasing. So that is a picture of the graph here for you. And it's right there. Okay. So how do you solve these problems? It's pretty easy, actually. You read the equation for magic words. So I say look for magic words. You're looking for the varies directly as, or varies inversely as. And as soon as you read the magic words, you write down either y equals kx or y equals k over x. After you read the words, you write that down. Then you look for what I call the fun facts. Look for fun facts and plug it in. That will let you find k. And then you will write your new equation and use it. Okay, so things you need to write down. Step 1, look for magic words. Step 2, write equation y equals kx or y equals k over x, depending on what the magic word said. Look for fun fact, plug it in, find k. After you find k, you'll write your new equation and use it. And after you do a few of these, I think you'll be right with me by what I'm talking about. So here we go. Let's do some examples here. Find the variation constant and an equation of variation in which Uh-oh, magic words. Y varies directly as X. That tells me, step 1, write it down. Step 2, look for a fun fact. Oh, this looks fun. Y is 32 when X is 2. So we plug that in. Y is 32 when X is 2. Now it says to solve for K. We just divide both sides by 2 and K is 16. Now that is the variation constant. They're going to ask you that. What is the variation constant? It is 16. Now, what is the new equation? The new equation then is y equals 16x because you plug in the value you found out into the equation. That's all you have to do. There might be a further step where they actually ask you to do something with it, and we'll do that here. This one is not using x and y. It's using a word problem, so I have to read carefully. The number of centimeters of water produced from melting snow varies directly as, so it says W varies directly as S. So usually we write Y equals KX, but now I'm going to write W equals KS because they told me different variables. Meteorologists have found that under certain conditions, 150 centimeters of snow will melt to 16.8 centimeters of water. Seems like a fun fact to me. Okay, W stood for water. So they did do this backwards than they could have. So 16.8 is the water equals K. S is the snow times 150. Now we can find the K. So go ahead and do that. As soon as you can find it, go ahead and find it, even though we haven't even finished reading the problem yet. 16.8 divided by 150, and my K is 0.112. Plug it into your new equation, and it's W equals 0.112 S. Variation constant, new equation. Now, as I continue to read, they're going to ask me to do something with my new equation. How many centimeters of water does 200 centimeters of snow melt to? So now that I know what the relationship is, I can plug that 200 in for S and find out how much water it will be. So the water is going to be 0.112 times 200. And you're looking at 22.4. How much water was it? Centimeters of water. So we wrote our equation, we found the fun fact, figured out what K is, read some more, plugged it in, used our new equation to solve a problem. Okay? Oh, that's what we just did, a little picture. Did that too. All right, next one. Find the variation constant in an equation of variation in which, oh dogs, y varies inversely as x. That tells me to write this down. Y equals k over x. Step 1, reading for fun facts. Here's all the fun. Y is 16 when x is 0.3. Can I figure out what k is now? Sure. I just multiply both sides by 0.3. So times 0.3, 16 times 0.3 gives me 4.8 for my k value. That is the variation constant that they're asking for. So what is the equation of variation? Just plug it in. Y equals 4.8 over x. And that's the variation constant and the inverse variation equation. Okay, let's fill a swimming pool. The time t required to fill a swimming pool, here it is, varies inversely as the rate of flow. So that's enough to write our equation. Usually it's y equals k over x, but because they gave me different variables, it's t equals k over r. It will tell you in the correct order. Now I'm looking for a fun fact. A tank truck can fill a pool in 90 minutes at a rate of 1,500 liters per minute. T was the time in minutes, so it's 90 equals k over the rate, which is 1,500. I can find k now. Multiply both sides by 1,500. Get a big one. So k is 135,000. That's the variation constant. So what's my new equation? I'm not going to use y, am I? T equals 135,000 over R. How long is it going to take the pool if the rate is 1,800? If the R is 1,800, I can plug that right into my equation. There we go. Divide by 1,800. I can do a shortcut if I want and cross those zeros out, can't I? 1,350 divided by 18, or you can just type it all in, and it will take 75 minutes. Does that seem to make sense? I think it seems to make sense. If it's going faster, it would take less time. Okay, there's other types of variation as well. You can combine the variation. So if it says varies directly as the square of x or the cube of x, it still says varies directly, which should mean multiply to you, but there might be an exponent there, and you might have to take the nth root of something at the end. Same thing with inversely. If it says inversely as the cube of x, you would write k over x cubed. So that's going to happen sometimes. If it says jointly, that means multiply. If it says jointly and there is more than one variables, it's going to be a super equation and it will be multiply. If it said jointly and inversely, you might have to multiply and divide. Then they would give you a super de-duper fun fact. And you can still use all the information to find K. So let's see what we have here. Find the equation in which y varies directly as the square of x. So my equation is not going to be kx, it's going to be kx squared. Now, here's my fun fact, 12 and 2. 12 equals k times 2, which is squared now. So you divide both sides by 2 squared, which is 4. And my variation constant is k, and my new equation is y equals 3x squared. Okay, how about this one? Find an equation of variation in which y varies jointly as x and z, that means multiply, and inversely as the square of w. So this is a big one. Jointly means multiply, so that's k, x, z. Inversely means divide the square of w, which would be w squared. So if I'm going to find out k here, they're going to have to give me a super fun fact, and they do. Y is 105 when x is 3, z is 20, and w is 2. So we're just going to clean up a little bit. 105, that will be 60k over 4. You can either multiply both sides by 4 first or divide first. That's up to you. 60 divided by 4 is 15, but let's go ahead and just multiply by 4. 105 times 4 will be 420. And that's 60k. Divide by 60, which is just the same as 42 divided by 6, and k is 7. So that's the variation constant, and my new equation would be y equals 7xz over w squared. So it's not too hard, just need to read carefully. Okay, I think this might be the last one. The volume of wood, which they're calling V, in a tree varies jointly, which means multiply, as the height and the square of the girth. So the equation will be, jointly means multiply, V equals height and square of G, which would be G squared. And what did I forget? That is bad, Mrs. Bruno. Just forgot the K. Have to have that, KHG squared. If, here's the fun fact, the volume is 216 meters cubed, when the height is 30 and the girth is 1.5, find the next thing. Well, let's find K first. So 216 equals, go ahead and multiply that out. 30 times 1.5 times 1.5, that's 67.5. Divide both sides by 67.5. And 216 divided by 67.5 gives me 3.2 for K. So my real equation is 3.2 Hg squared. Now I can find the answer they're looking for because they want to know what the height will be. If the volume is 344 and the girth is 1.6. So again, we can clean up first. Just take 3.2 times 1.6 times 1.6, 8.192 h, divide by 8.192, and it will tell us the height of that tree. Looks like it's about 42. 41.99, we'll say 42. Looks pretty good. So plug those values in, use that fun fact and find it, and that's all we're doing today.